Alright, so today what we're going to look at, class, is we're going to look at comparing fractions and how can we compare two different types of fractions that are a little bit harder to identify with or to see. So what I've asked the question here is I've asked, well, which is bigger, 2/3 or 7/12? And up until now, the only way we could really do this is by using our fraction chart or by visualising. If I had here a circle, and my first circle I have divided it evenly into 3 equal parts, so I've divided it equally into thirds. Alright, so each of these represents 1/3, 1/3 and 1/3. And then over here you can see that I've given myself a circle that's been divided evenly into 12 segments, 6 either side, and exact same circle, but each one of these segments represents 1/12. And I'm asked the question 2/3 or 7/12, which is bigger? So imagine that these were 2 cakes and I was offered 2/3 of the pizza of the cake or 7/12 of the cake. So which one would I choose? Well, by visualizing this is going to make things a lot easier. 2/3 is 2 1/3 segments, so I'm going to colour in my first one here and my second one. Okay, and so you have an idea there of what 2/3 of the cake would look like. And the other option I was asked is 7/12. Well, what does 7/12 look like? So again, I'm going to colour in 7/12. So 1, 2, 6, and the last one here is 7. So I'll count through those again just to make sure. 1, 2, 3, 4, 5, 6, 7. And so if I was to offer you 2/3 of the cake or 7/12 of the cake, which one would you choose? And visually we can see that definitely the 2/3 one, this one here, the 2/3 is much bigger than the 7/12. Not much, but you know, definitely worth picking this one. But the question is, can I do this without making a diagram for each one? And I can. I'm going to show you a method how to do that. All of the previous work that we've learned with regards to natural numbers and integers, everything in maths is a building process, so we haven't forgotten anything like that. And I wanted to first of all look at the bottom numbers here, 3 and 12, which means we're dealing in thirds with this one and 12ths in this one. And I'm going to ask us to select the lowest common multiple of 12 and 3. Alright, so my multiples of 12 are 12, 24, 36, 48. Just going to stop there. And I'm now going to do the multiples of 3. And they are 3, 6, 9, 12. And I'm going to stop there because I've actually realised I've gotten my lowest common multiple. My lowest common multiple between 12 and 3 is 12. So I'm just going to circle that. Okay, so the LCM is equal to 12. And in fractions, another word we use for the LCM is the common denominator, because this is a number that both my denominators go into. Remember, numerators were on top, denominators were on the bottom, and a common denominator is a number that both of the numbers on the bottom go into. Okay, so what I'm going to do now is I'm going to use my lowest common multiple to help me figure out which one of these is bigger. The first things first is I write 2/3 is equal to something over 12. Alright, and the second step is 7/12 is equal to something over 12. And I'm going to do the same method that I've used for equivalent fractions. So I ask myself, 3 goes to 12. What do I do to the bottom here to make 3 go to 12? And the answer is I multiply it by 4. And if you remember, what I do to the bottom, I must do to the top. And so I'm going to draw my multiply by 4 up here. And 2 multiplied by 4 will give me 8. So I can now write 2/3 as 8/12. That is an equivalent fraction, which means an equal fraction. Alright, and now I'm going to go over here to my second side, and I'm going to again ask myself the question, well, what do I do to 12 to make it go to 12? And obviously I don't do anything, and if I perform any operation, it's just that I multiply it by 1. So what I do to the bottom, I must do to the top, and 1 times 7 gives me 7 over 12. And so now I have 8 over 12 and 7 over 12. And I can easily see which one is bigger, the 8 over 12. So 8 over 12 is the bigger fraction between 2/3 and 7 over 12. So my methods are find the lowest common multiple, and then I'm going to use my equivalent fraction method to help me. Alright, let's start into one more example here, and this question says which one is smaller? So we're comparing these two fractions, and it is 2/6 and 3/8. So again, we're going to do this by a method, a written method, not a visualization, and we're going to use the LCM. And we're going to use the LCM of 6 and 8. So we're going to work on those and figure out what is the lowest common multiple. Well, my 6 times tables are 6, 12, 18, 24. I'm going to stop there and move on to my 8 times tables. And I've got 8, 16, 24, 32. And if I'm awake, I should have realised that I've come across my lowest common multiple. My lowest common multiple between 6 and 8 is 24. So that's my first step done. I'm now going to write 2/6 is equal to something over 24 on one side. And then over here I'm going to write 3/8 is equal to something over 24. And I'm going to go back now and solve. So, equivalent fraction method. What do I multiply 6 by to get 24? And the answer is I multiply it by 4. 6 4s are 24. So what I do to the bottom I must do to the top. And 2 multiplied by 4 will give me 8. So I now have 8 over 24 here. And 3/8 I'm going to apply the same method. So what do I multiply 3 by to get 24? And it's 8 3s are 24. And what I do to the bottom I must do to the top. And 3 3s are 9. So, which is the smaller fraction? Is it 8 over 24, which is the same as 2/6, or 9 over 24, which is the same as 3/8? And hopefully everybody has realised that the smallest fraction in this case is the 8 over 24, which is equivalent to 2/6. So 2 over 6 is our answer. Alright, just a little bit of a learning check then this evening. And it is to figure out which one of the following in the first 2 questions is bigger and in the last 2 questions is smaller. Remember to show your workings, your arrows, and your lowest common multiple, how you figured it out, okay? And I'll see everybody tomorrow.